Today is day 2 of Olympiad starters. We are doing a sum in basic number crunching that involves divisibility of numbers. So, if the number 4a3b is divisible by 11, how many pairs of a and b are possible? Now, when do you say a number is divisible by 11? We say a number is divisible by 11 when the difference of the sum of the numbers in alternate places is 0 or a multiple of 11. For example, if you have a number of the form 2, 5, 9, 8, 4, 7. Okay. We take the number in alternate places and add them. And okay, 5 plus 8 plus 7. Okay. Now, what do you get here? You get a 22 and you get here a 15. Okay. Now, what is the difference between these two? It is 22 minus 20, which is equal to 2. Now, is this 2 a multiple of 11? No, it is not a multiple of 11. So, I can say that this particular number is not divisible by 11. Now, this basic divisibility rule of 11 is something that you learn in grade 5 or 6. Now, let us apply the same rule to this particular sum. Okay. So, here I have written down the condition for this number to be divisible by 11. So, I have taken 4 and 3. So, 4 plus 3 minus a plus b or a plus b minus 4 plus 3. The reason being, I don't know if this is a larger value or this is a larger value. So, I have to consider both possibilities. So, 7 minus a plus b or a plus b minus 7 has to be equal to 0 or a multiple of 11. Okay. So, I will take it case by case. So, what is my first case? Case 1 is a plus b minus 7 is equal to 0. Or I can say that a plus b is equal to 7. So the sum of two numbers is equal to 7. I have to find out the combinations of two numbers that give me a sum of 7. So what are those numbers? So if I am writing a and b here, 0 7, 7 0, 1 6, 6 1, 2 5, 5 2, 3 4, 4 3. Correct? So I am having how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. I am having 8 numbers over here that gives me a sum of 7. So this is my first case. Now what is my second case? My second case is 7 minus a plus b is equal to a 0. It gives me back the same case. Okay, so this and this are both the same, both imply the same conditions. So I don't need to take them separately. Okay, now I deal with my case 2. What is my case 2? After 0, I need to see whether this is a multiple of 11. What are the multiples of 11? The first multiple of 11 is 11 itself. So, let me see whether 7 minus a plus b is equal to 11 is possible. So, 7 minus a plus b will give me a plus b is equal to minus 4. Correct? So, this is not possible. Right? Now, let me look at the next condition. Case 3 where it is a plus b minus 7 is equal to 11. Or I can say that a plus b is equal to 18. This particular value of a plus b is equal to 18 is only possible if both a and b both are equal to 9. No other value is possible because if you are taking any other value for a, then b will become a 2-digit number. Okay. So, I have a and b which is equal to 9. Okay. Now the next case, which is my case 4. What is my case 4? The case 4 says that a plus b minus 7 is equal to the next multiple, which is 22. Or a plus b is equal to 29, which is not possible unless we assign a 2-digit value to either a or b or both of them. Correct? So, case 4 is not possible. So, from this part, whatever numbers or combinations we are taking as a multiple of 11, it is not going to be possible. So, what are the possibilities that we already have? We have 8 combinations here. We have 1 combination here. So, how many pairs of numbers actually satisfy this? 9. I hope you have understood the sum. This is basic. This is using just basic divisibility of numbers and trial and error of a few cases. I am giving another sum for practice. If the number 85 is divisible by 9, how many pairs of A and B are possible? So here I know what is the divisibility rule of 9. The divisibility rule of 9 states that the sum of the digits of the given number should be divisible by 9, right? So A, B, 5, the sum of the digits give me A plus B plus 5 has to be divisible by 9 means it has to be 9 or a multiple of 9. So this is equal to 9 or multiples of 9. Now in this case we need to see which are the multiples that are actually possible in this case. So what is the maximum value that A and B can have? A and B can have a maximum value of 9 and 9. So the sum of the numbers, what does it become? The sum of the numbers actually become 23. Correct? So I need to find, so the maximum sum that can come is a 23. So below 23, which are the multiples of 9? Below 23, I have got 9 over 18. Okay? Now let us see different cases. Case 1, A plus B plus 5 is equal to 9 or A plus B is equal to 4. So what are the combinations of A and B that I can have? 0, 4, 4, 0, 1, 3, 3, 1, 2, 2. Now you know that 0, 4 is not possible. The reason being the first digit cannot be a 0. It becomes a 2-digit number. So this is not possible. So these are my remaining possibilities. In the second case, 18 or A plus B is equal to 13. So what are the different possibilities that you can be having with this sum of 13? Okay. I have written down all the possible combinations of A and B over here. So how many pairs are in total possible? Here I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can have 10 pairs of A comma B combinations which can satisfy this particular condition. Okay. I have given two sums over here for practice, and I would want you to do the sum so that you get a better understanding of how to use this particular concept. It is not a nerve-wracking concept. It is just the basic divisibility of numbers and a different way of using it. Instead of asking whether this particular number is divisible by 11 or 9, they are just masking 2 or 3 digits and asking you to find out those digits by using the same concept.